Alright, the moment we have all been waiting for. EOS Dawn 3.0 is now available. And Dan just posted this article. He just posted it in the Telegram. I'll link this down below so you guys can read it. It's basically an overview of everything that they've added in for Dawn 3.0 and where they're going in the future. It's pretty detailed, and I've highlighted a few points, and I'll go through and basically add my own commentary to it. But it's a great read. I recommend everyone go through it. And here's the big news, guys. Block.one is excited to announce the first feature-complete pre-release of EOS, aka Dawn 3.0. So feature complete basically means they're done with all the features, they're done writing the functionality. Now they just got to do the updates, the upgrades, and fixing things like bugs going forward before the EOS official release in June 2018. So the first thing that we have highlighted, scalability features, right, is the big problem with blockchains. So scalability to EOS means the ability to scale to meet market demand. At every step, our team has factored future scaling needs into the design. That said, Dawn 3.0, which is now released, only implements a fraction of the potential optimization that will allow EOS to scale. We have designed EOS so that future implementations can utilize parallel computation to accelerate throughput without hard forking changes. So Dawn 3.0, it is a big step, but there's huge room for future optimizations and huge potential going forward. And how do they do this, you may ask? Well, inter-blockchain communication. Inter-blockchain communication is the ultimate scalability feature, the holy grail that the industry has been searching for with proposals such as sidechains, plasma, and sharding. Inter-blockchain communication enables one blockchain to verify the authenticity of an event on another blockchain in a provable, secure manner. The goal is for inter-blockchain communication to be as secure as intra-chain communication between smart contracts, and we think we have achieved that goal. So they're basically saying that inter-blockchain communication should be just as easy as inter-smart contract communication inside a blockchain, and they think that they have achieved that goal. They think that, and that's huge, because now you're saying, all right, blockchains can communicate just as easily as smart contracts can communicate. Super important. From our perspective, inter-blockchain communication is nothing more than having the ability to implement a light client as a smart contract. And what is a light client? A light client is a client that is able to validate transactions from a blockchain without having to process the whole thing. So the whole big scaling problem with blockchains are every node has to download and run the entire thing. And over time, it's going to grow and get gigantic, right? So we're going to have to be able to validate transactions, and you don't want to download the entire thing just to validate transactions, and that's where light clients come in. So how do they do this? Well, we have sparse header verification. Traditional light clients are expected to process every block header. The problem with that is that this does not scale for scenarios where there is relatively infrequent inter-blockchain communication, like every blockchain there is right now, right? So to solve this problem, we created the first blockchain with Bytesdian fault-tolerant sparse header validation. Specifically, it requires more than 2/3, and if we're talking to 21 block producers, it requires 15 or more of these 21 block producers to be corrupt in order to attempt to deceive these light clients. So EOS light client idea will work as long as 2/3, and let's hope not 2/3 of these block producers are corrupt, which I hope none of them are corrupt, but this works as long as no more than 2/3 of them are. And this dramatically reduces the overhead in maintaining a Bytesdian fault-tolerant light client and dramatically increases the efficiency of inter-blockchain communication. That's great. Another thing they have, context-free actions. And context-free actions are one of the key features that enable efficient inter-blockchain communication. They are special actions that can be included in a transaction, yet do not depend upon blockchain state. Hence, they're context-free. So when you have a giant state machine and you got to depend on what state you're in, it can be complex, and you're gonna have to wait for things to be done and so forth. But when we're talking this parallel asynchronous communication, things like context-free actions can be done. And because these computations are context-free, they can be trivially validated in parallel, and the computation can be pruned from the replay. Context-free actions enable us to parallelize the vast majority of the overhead associated with inter-blockchain communication. That's great. That's going to speed up the slowest part, essentially, right? And get this, they also enable us to parallelize and prune the overhead of computational expensive privacy techniques, such as confidential transactions, bulletproofs, and ZK snarks. So that's huge. If you can add privacy into this super fast scalable blockchain, that's huge, right? And that's great that you can that they've designed this where we can add in privacy features to it in the future. In order to incentivize the use of context-free actions, block producers only charge users a fraction of the CPU usage when a calculation is performed as part of a context-free action instead of as part of transitional transactions. So less CPU usage when you're using context-free actions. And then you also have context-free inline actions as events. An inline action is one that is generated by contract code and executed as part of the current transaction. A context-free inline action can be processed cheaply and in parallel. Again, their parallelism. And we also have transaction compression, which is great because if you have large data that you can compress and make it smaller, why not? And there are many transactions that have a lot of compressible data. So if you want to utilize transaction compression, the blockchain can more effectively store and transmit large numbers of transactions and, get this, bill users less for transactions with compressible data. They also changed their interpreter and their just-in-time compilation. So Dawn 3.0 now utilizes the binarian WebAssembly interpreter by default rather than the just-in-time compiler. The interpreter also solved one of the biggest challenges they faced with Dawn 2.0, which was the delay caused by compiling a contract. In the future, we can use the interpreter to get a slower but lower latency execution of freshly deployed contracts while we compile and optimize the contract in the background. All right, another big thing they added, which a lot of people were asking about, is resource metering and rate limiting. We now utilize a hybrid solution where users are billed for objective use, but block producers place subjective wall clock time limits on contracts as well. These subjective limits prevent abuse of variance in the objective billing. It is now theoretically possible for a block to include a single transaction that takes 100 milliseconds to run, whereas in the older model, every transaction had to run under 1 millisecond. So there's more flexibility with that. And this is another cool thing. Another change to rate limiting is the separation of limits from the need to define a token. This allows EOS.io to be used in private permissioned blockchains without any use of tokens. So it's arguably that the whole point of blockchains is to be open, to be public ledgers. However, if you are so inclined to create your own private permissioned blockchain and you don't want to use any tokens, you can do so with EOS. Another big thing that they finally did is now they finally got to their 500 millisecond, their half-second intervals of block times. And they also finished their Bytesian fault-tolerant DPoS, delegated proof of stake, where transactions can be irreversibly confirmed in under 1 second. So you have finality in under a second, where I think it's like 30 minutes till finality in Ethereum right now. The latency until irreversibility has major implications for inter-blockchain communication because another blockchain must wait for irreversibility before incorporating a proof from a foreign chain. This is important here, two EOSIO-based blockchains should be able to perform a round-trip communication in under 3 seconds. And here's the comparison to Ethereum. A similar communication pattern on Ethereum would take 9 minutes, and on Bitcoin it would take 3 or more hours. Another cool thing is the BIOS architecture. Under EOS Dawn 3.0, the vast majority of the blockchain business logic has moved into a smart contract which can be dynamically updated by the community without a hard fork. So what this means is the vast majority of the software is made into smart contracts that can be hot swapped at any time, changed out, modified, and put back in. So here it is. A bare bones EOSIO blockchain is now a single block producer without any tokens, voting, or delegated proof of stake. So the delegated proof of stake is hot swap and changeable. The only thing implemented in the core blockchain code is the permission system, which includes the ability to create accounts, deploy contracts, and enforce resource quotas. Everything that makes the blockchain delegated proof of stake, including the tokens, the voting, the staking, and the resource allocation, is now defined by the WebAssembly-based smart system contract. So, stripped down to its core, it is only the essentials, and everything else is configurable. With this new, So down here, another cool thing, security features, right? This is a statement from this article here, is we have designed EOSIO to be the most secure blockchain on the market. And the way they go about this is pretty much different than everyone else, I believe. Security delayed transactions. So now you have a user configurable delay for different actions. And with this delay, a transaction must be broadcast to the blockchain for a number of hours or even days before it can be applied. So now during this delay period, you as a user can take measures to reset your account with higher permission levels and cancel the transactions. So now if you get hacked in, say, Bitcoin, and someone moves your funds, it's over, it's game over. But now you can set up these time delay transactions. So if someone hacks your funds and tries to take your funds, you have a certain period where you can just cancel that. And you also have lost password recovery. So the owner permission level can reset the active permission at any time the active key is lost or stolen. So if you lose your owner key, you have multi-sig partners that you can trust as well to secure your funds, and let's say they become uncooperative, then the account active permission can request a reset of the owner permission after 30 days of the owner permission inactivity. So the owner authority then has 7 days to challenge the request by updating the active authority. So here's the cool part. Under this model, an account owner permission controlled by one or more hardware wallets will be secure against hacking and device failure. So let's say the device was an Apple iPhone with hardware and fingerprint and Face ID securing your private keys, then the hacker would require compromising your multi-sig partners that you trusted, B, physically stealing your phone, and then stealing your fingerprints, and then stealing your face. And ideally, you say your multi-sig partners also set this up, so then the hacker would then need to steal your multi-sig partner's phone, and then their fingerprints, and then their faces as well. So it's super secure. So when they say that they're the most secure blockchain, this is how they prove it. They also have a transaction proposal system. So with the proposal system, anyone can propose a transaction, and the parties involved in this transaction can simply approve or deny it. And there's the time period is varying, and at any time can people approve this transaction or deny it if you have multiple people involved in that transaction. And we also have simplified smart contract development. So basically one of their goals is to make smart contract development as simple and painless as possible. And they have a new Hello World example, which is 13 lines of code, right? I believe they also have a new currency contract, which I'm really excited to learn that one and get that one running. That one looks pretty interesting. They also added floating point support. And another big one is the C++ Standard Template Library support, STL. And this is huge because this means developers can use the tools, libraries, and algorithms they are familiar with while eliminating the potential for bugs caused by non-standard implementations of these algorithms. Now, Standard Template Library, C++ has been around for a long time. I mean, there's books on this. I mean, here's one I even have data structures and algorithms in C++. I mean, this is like what you learn in college, right? This is tried and true libraries and code libraries and things like Ethereum. They're trying to write all this stuff from scratch, and why reinvent the wheel, right, guys? So that's really important in my eyes. We also have scheduled transactions. You can now write contracts and operate forever, provided that you have the sufficient funds staked. You can just have a contract that just runs for the rest of its life forever, right? Other platforms require off-chain solutions to wake up a contract at appropriate times. Don't need to do that in EOS AO. Automatic scope detection. I talked about this in my smart contract programming video, actually. Now you don't have to specify your scope. I believe block producers are responsible for determining the data ranges, and hopefully deconflict them. Hopefully you will not have conflicts between contracts interfering with each other. Multi-index database API. I guess they're now using the Boost multi-index container. This is great because it's trivial support for database tables, sorted by multiple keys, find items, use lower and upper bounds. They also have indices in 64-bit, 128-bit, 256-bit, 512, integers, as well as 64-bit floating point doubles, right? And here we go, guys. Performance. What we've all been waiting for. How many horses you got under the hood, right? And they go in and they talk about all the test cases and benchmarks that they ran for their performance, and that's one thing that everyone focuses on: how many horses you have under the hood, right? So they go through and they outline a few of their benchmarks of what they're hitting for performance right now. At the worst case, they have 1,000 transactions per second. At our baseline performance with no optimizations, they're able to sustain 1,000 transactions per second. All right. Average case, 3,000 transactions per second. Once you turn on the just-in-time compiler, you can sustain 3,000 transactions per second. All right. Best case, 6,000 transactions per second. And let me read this one. Once we implement parallel signature verification, we can assume the wall clock time per signature will approach 0 as the level of parallelism and the number of signatures increase. Under this model, we can hit 6,000 transactions per second on a multi-node network with a just-in-time compiler. Okay, theoretical case. Now, if you just remove the networking stuff and focus on what the CPU is capable of doing with a just-in-time compiler, we can hit 8,000 single-threaded transactions per second. And the just-in-time compiler gives you 3 times the performance. All right, so that's what everyone's saying. Well, that's not the million transactions, they said. Come down here, unlimited transactions per second. So this is what you guys want to hear. The big enchilada, unlimited transactions per second. So Dan goes on to say, the definition of transactions per second is often an apples to oranges comparison. Imagine this. With 1,000 chains operated in parallel, by the same or different block producers, we could see millions of transactions per second. This represents a practical realization of the theoretical scaling proposals presented by other blockchains. So think outside the box here. Think thousands of chains all being produced by different block producers that are producing multiple of these chains, and all these chains can talk to each other. And all these chains are using Bythesdian fault-tolerant delegated proof of stake, where all the block producers are voted in and voted out based on a voting mechanism. And this sounds like a great, or this sounds like a really good compromise between complete full decentralization and delegating some sort of centralization for block producers, but still keeping the network very decentralized with all these different chains, and keeping the performance up to par where it needs to be. So he also says, we strongly encourage block producers of ESIO based public networks to operate as many chains as necessary to meet user demand. All chains could use the same token as the basis for staking and resource allocation. Big note right there. This will create the maximum possible network effect around a single token and leverage the trust and security of economic incentives created by high market capitalization tokens. So imagine multiple chains, but if you do use the same token on all these chains, if they honor that token, you get the maximum possible network effect to leverage the trust and security of economic incentives, right? It makes sense. So when you're talking scaling, guys, when you're talking sharding or plasma cash, lightning, raising the block size, I mean, Dan says, just make everything parallel and have them talk to each other, and you can achieve great scalability, great performance, and still keep things relatively decentralized. So that's about it, and I encourage you all to read through this. And I'll be downloading Dawn 3.0 off the GitHub, and I'll be looking into that, hopefully making more videos on Dawn 3.0 in contracts, smart contracts, and programming. So, all right.